Well, good evening from Emerald Hill Skies on the outskirts of Louisville, Kentucky. My name is Doug and happy to be with you here tonight. It's a chilly night. It looks like on top of the scope we're reporting somewhere around, let's get the temperature if I can find it, 18.1 degrees Fahrenheit. 18.1 degrees Fahrenheit. So that's kind of nippy, isn't it? But I think we've got things working again. The sky cam and the power box is working again. It looks like we have around 10 people already on the stream. If you guys don't mind, kind of go ahead and tell us where you're logging on from. It looks like Angela's from Glendale, Arizona. Mike is from Georgia. And Azray, of course, from Arizona. Good to have you guys on board. Anyone else, if you would, just go ahead and log on. Of course, tonight, the big news is the Comet, and our media continue to give us a good ramp up to that. Comets are cool, let's face it, so let's get going. You know, we're using a RASA 11-inch scope, and it's on an equatorial mount, an iOptron CEM70G on top of an adjustable height frame, so it looks a little bit like this out there at the observatory. This is not a live picture, but most of the other shots I'm showing you are live. This is captured to give you an idea of what that adjustable height frame looks like raised up above that roof. You lower it and you can slide the roof back on. You guys that have been on the channel before, you know we use a ZWO ASI2600MC Pro astro-specific camera. It's a color camera, one-shot color camera. It's fastened to a special interface, and it's made by Octopi-Astro. That camera interface helps you align things. It sits on top of the glass corrector plate. Power box is working, so our dew strips are working again tonight. That corrector plate makes a slight adjustment to the light when it enters, hits the mirror, comes back up, and centers on the camera, we hope. At the bottom of the scope, we've got this rig rack to run all the wires through. On top of the scope, we've got this ZWO boy, I've got a mental 178, I think it is. Had a mental block there for a second about that monochrome camera, and it gives us pictures like these. Lets us be able to view that sky, and you can see it's pretty bright tonight. Looks like a few wispy clouds floating by, but for the most part it's okay. And you know, we're looking forward to showing you this picture of the comet itself. So this is a live picture of the comet. We've been stacking around 6 minutes and 20 seconds. And you know, we were noticing last night that when we zero in on the comet, that's 100% right there. We zero in on the comet and start live stacking. You know, the comet's moving in relation to the stars. So the body or the head of that comet, I think we said last night, what is it, about maybe 1 kilometer in size. As it streaks across the night, what did we say last night? 128,000 miles per hour, right? 128,000 miles per hour. And didn't we say last night that it was roughly 27, was it, million miles away? But as it hurtles across the sky so quickly, it moves in relation to the stars, and our mount is following the stars as they appear to revolve, you know, around the Earth. Actually, it's the Earth rotating, but it looks like the stars are revolving from the eastern horizon over to the west. So the comet, because it's streaking so fast, it actually creates this odd little streaking pattern here. That's the head of the comet as it plows through the night. But last night we were noticing that all of that gas and ice and the chemistry that's being lit up by the sun with ultraviolet light and all that gaseous stuff around, cyanide and carbon dioxide, and everything's boiling off, that stuff makes a kind of a halo around the comet. And as that comet plows through the sky, the halo kind of stays hanging beyond. So the head is moving, so the brightest part of the comet is the core, and it's moving, but it's leaving behind it, because we're taking 20-second exposures and stacking them on top so we can get a better look at this halo effect around it. That creates that little, what would you call that, like a black ditch in the sky. And then up here in front you can see the brightest part, which is of course the core. Now if we look at where we're looking here in the sky, this is a planetarium software called Stellarium. And Stellarium is basically just a map of the sky on computer, so you can kind of see where you are. So looking at our map tonight, you can see the Big Dipper right here with the cup, and then those two end stars on the cup that are pointing at the North Celestial Pole. The North Celestial Pole, shown here by the letters NCP, North Celestial Pole. That's the end of the Little Dipper, of course. If you follow the handle of the Little Dipper, almost exactly on the meridian, there's the comet. And in just a few minutes, we're going to be into the meridian, aren't we? We're going to have to do a meridian flip, I bet, before it's over. But right now, we're at, what altitude would that be? Probably around 70 degrees up in the sky. Yeah, 70 degrees up in the sky, and the moon is right here. So again, we'll get that angular measurement so we can see how far we are. I always tell people, no sense in trying to look at something that's within 20 degrees of a full moon. And we're tonight within 41 degrees, so pretty close. But, you know, we're still able to see it at least. Even though we're 41 degrees away, still able to make it out. But that moon is so bright tonight. We are looking at tonight a, was it 98%? A 98% moon. So you might as well say it's a full moon. And some people say we're kind of crazy to try to image something like a comet tail, you know, on a night when you've got a full moon. But I always look at it like, you know, let's don't let the moon rain on our parade. Let's go ahead and you know, let's observe the way we want to observe. And let's observe what we can observe on a full moon night. So we'll see what you guys are saying here. There's Witchy Crone from northern Wisconsin, 3 degrees. That just makes my fingers crack open just thinking about it. Barbara, good to have you on board from northern Wisconsin. Wow, that's like the snowshoe capital of the country or something. Azray is in Glendale, Arizona. Andy, good to have you back. Andy Crabtree. David, good to have you on board from New Brunswick, a small village of St. Cecile at 10 degrees Fahrenheit with a very strong wind and with snow coming down. Brrr, makes us all just shiver. David, I hope you've got some cocoa or something there. Anything is good to look at when you're that cold. So again, when we look at tuning this up now, let's do another color balance here. So what we're doing is we're using, this is SharpCap Pro, and we're using our auto color balance to get it started. Now what we're trying to do is align these bars so that they all get pretty much with their crests aligned. Let's see, the red will have to come up. Maybe we can take the blue down a tinge. We can take the green up, and the red can stay there, I guess. Although it really needs to come up according to those color bars, doesn't it? There we go. Now the red is pretty well aligned, so we'll bring this black level up to about right there. Somewhere around right there. And then we can probably bring the mids up a little bit. So everybody's asking, well, why is it so green? I mean, aren't all comets greenish a little bit? It seems like, I mean, I've seen two, so I'm no expert. But it seems like they all have a tinge of green. It's just all those gases burning off, being cooked by the heat of the sun and the ultraviolet rays. But this comet seems a little more green than normal. It must be that cyanide sort of stuff that's cooking out of the middle, and carbon dioxide. I think whenever you see green out there in space, it usually means there's some oxygen being cooked up, and that's probably what we're seeing tonight. So this is 20-second, these are 20-second frames, and we're stacking them one on top of the other so we can catch as much of this halo as we can. And Pete Gallup. Oh my goodness, Pete. I'm going to do the math here real quick. See, 5 hours for the Isle of Wight. So it must be 2 a.m. You must have gotten up. You must have gotten up to have to go to the bathroom or something in the middle of the night, Pete. And you thought you'd stop by the laptop, the computer, while you got up in the middle of the night. Pete, it's good to have you aboard. Whenever you can get up in the middle of the night like this, we have deep respect for you, brother. I'm still not sure my colors are right. Let's see. What is that color right there? I'm just not very good at colors. That must be blue. So we'll bring that down until it matches. And this one, there we go. Now that's almost a perfect match. And so if we're just going to do it by the bars, I mean if we're going to do it by the color, the crest of the color waves, in other words, if it just by calculation only, then this is roughly where we would be. And kind of bring that black level up just a bit, and then we'll bring the mids up a little bit to kind of make those brighten up. What are you guys thinking? There's not a very pronounced tail, but I was saying last night that in a way you could understand why there's not much of a tail, because boy, I think we are kind of seeing a little bit of a tail tonight, aren't we? We're seeing a fat tail, a very fat tail. You can understand why there's not much of a tail, because all of the sky is extra light because of this moon. Oh, and look at those wispy clouds starting to roll through too. Those wispy clouds, those rascals. That's starting to give us a little bit of a problem as well, but not too much of a problem. And look at the accumulation of light here. Notice how on this side of the comet we're accumulating all of this kind of halo, and then over here it's just dark as can be. So you might be saying, well, why is the tail not behind the comet, which is what you'd expect as the comet flows through the sky, because most people think the tail is kind of like the flume of the rocket engine when the rockets launch from Cape Canaveral. But this is not a rocket flume. This is a reaction of all of the gases and the ice being sublimated off the edge, kind of forming a sort of a plasma out there in space, and then being lit up like a neon light. And it's the sun, and it's solar power, so to speak, that's lighting this thing up. Now the telescope is on its side, and if you can picture, this camera is looking from behind the scope toward the North Pole. If you could look straight up in the sky, you would see the North Pole. Now right there, that's not the comet that you see going by. That is definitely some kind of a satellite or a plane or something there. But anyway, we're looking behind the telescope as if over its shoulder toward the North Pole. So the telescope is kicked over toward the west, and the weights are toward the east. So the weights, that means left is toward the north, and in this case, east is down. So the sun would be in the direction of down. So let's remember that. No, wait, the sun just set over in the west. So the sun is in the direction of up. So see, that's exactly what we're saying. If the sun is up here, it's blowing with its solar wind and its ultraviolet light. It's blowing, boy, that airplane or whatever that was just came right through our scope, didn't it? It just plastered right through our scope. Thanks a lot. So you would expect the tail of the comet to be away from the sun. That's what you would expect. We'll see what you guys are saying here. ASRAY, if you use the zoom on the live stack histogram, it will show you a better color scale. Use the zoom. Now there's the zoom, but I am not seeing much of a color scale there, brother. Not sure what that should look like, but that doesn't look like, to me it doesn't look like as good as this one. This one to me works just fine for right now. Gooseberry and his Funny Farm, you're doing a great job. Thank you for your hard work. You're very kind. Gooseberry and his Funny Farm. ASRAY, that is light pollution at work. That's exactly right. China's balloon. I bet that's what that was. Andy, you are exactly right. That's that balloon. If you guys have not been following the news, there is a balloon. China says, oh, it's a research balloon. And we lost track of it. So it's flying over your country. Now move the slider at the bottom. So you're saying put the zoom on here and then move the slider at the bottom? Boy, I must be missing something. ASRAY, this is not really working for me. But this feels right to me, brother. Let's grab a picture of this before the meridian flip. And now let's go back to Stellarium and see where we are. We are already past the meridian, and I'm thinking we might as well go ahead. Let's go over here and look at our scope. Well, I'm not seeing the not seeing the measurement I want to, but I tell you what we're going to do. We're going to go ahead and stop this live stack, and we're going to go to 10-second frames and show you a live picture not stacked. So this is what it looks like if you're not stacking it. It's behind the label. Boy, I'm going to have to check that out again, ASRAY. So this is a live shot that's not being stacked with those frames one on top of the other. You can still see that even within the 10-second exposures, there is just a slight movement of this comet. Enough that even during 10 seconds, at least at this focal length, this is about what? 400 and, trying to remember, is it 420, I think? 420 millimeters focal length, the RASA 11. Even at 420 millimeters focal length, there's enough movement at this fast racing comet that during a 10-second exposure, it's enough to make the core look a little bit oval. This is 100% of our APS-C frame, and you can see there's a little bit of atmospheric disturbance tonight. Let's look at the sky cam. Yeah, see those wisps of clouds that are kind of wafting in and out? Yeah, you can watch them sort of flow past. See down there at the bottom of that view, that is, see if I can get my mouse onto that screen so I can gesture. Down here at the bottom, this stuff that's moving past is wispy clouds that were not supposed to be here. The forecast was for 100% clarity, 0% clouds. But this does at least show us the movement of the clouds, doesn't it? And so the comet would be, let's see if we can find where we're looking at here. See if we can get oriented. There's Cassiopeia. And here's the Big Dipper. So the Big Dipper is pointing. So that would be the North Celestial Pole right there. That's the North Pole. See, remember our scope is over on its side. So if we go up from the North Celestial Pole to about right here-ish. Okay, remember what that North Pole looks like, and remember these two brighter stars. Remember this one's kind of a visual double there. Let's get a picture of where we are in this triangle. Let's think about this triangle. Here's Polaris, there's Aldebaran, and here's a star that starts with an M that I can't remember how to pronounce. So in that elongated triangle, let's go now to Stellarium, and let's get a picture of where we are in that triangle. So here's the North Celestial Pole, and there's, did I say Aldebaran? I should have said Capella. Here's the North Pole, there's Capella, there's that star I can't pronounce, Minkalanan, we'll call it. So we're looking at halfway along the way to that, halfway along the way to Capella, and a little bit on the Capella side. It's not quite exactly, a little bit on the Capella side. So now let's go back to the, this is a live sky view through the 178, the ASI-178. Let's get oriented again. Here's the North Celestial Pole. Here's Capella. Here's Minkalanan. Here's Minkalanan. So we're talking about the comet being right here, a little bit on the Capella side. So the comet is right there. Let me brighten this up and see if, not a chance, is there? We can see this. This is now 3 seconds at 400. That's a little too bright, wouldn't you say? Let's go back down to 300 and be happy at 300. Okay, so North Pole, Capella. So right in here is where we need to look. Remember, we're kind of over on our side. North Pole, Capella, Comet, right here. North Pole, Polaris, Capella, Minkalanan, Capella Minkalanan, C 2022 E3 ZTF, right about there. It's pretty fun, isn't it? One more look. North Pole, Capella. Got a nice little ring of stars here. Look, these two stars would help us, because basically what you've got is North Pole through that star to Capella, Minkalanan through that star toward the North Pole. So right in between those two stars is where this comet is. Now let's see if we can see those. This is the live view of the 178. I don't know if I can make this bigger for you. No, you're already seeing it pretty big, aren't you? Let me try to make it a little bit bigger. Okay, so North Pole, Capella, two stars right here. Now, would it be right there where that little dot is? Now, that's not quite in the middle. Let me make this a little bigger for you. Covering up the text, aren't we? I wonder if I can make that text on top. There we go. Okay, so what we're going to go look at in Stellarium is if the North Pole wispy clouds, rascal, wispy clouds. But right here are two pointer stars, and right here in the middle, is it a little bit closer to this star than it is to this one? That's the question. Is that the star? Now let's go back to the Stellarium. It is, isn't it? It is closer to that star. And when you zoom in, well, there is this star, and that's magnitude 5.2. The comet is judged to be at magnitude 5.5. Notice there are 3 stars in a row here. So there's the, no, here's a pointer. Is that the pointer? Yeah. Here's a pointer and there's a pointer. Right in the middle and a little bit toward Capella, there are 4 stars in a row. 4 stars in a row. And from the Capella side, count them off. 1, 2, 3. Not that far from 16 Camelopardalis. 16 Camelopardalis. Okay, so let's memorize that. 4 stars. Now let's go back to the live view. Okay, there's Capella. Tell you what, let's zoom in a little more here. So here are our 4 stars. So that, right? 1, 2, it depends on whether that counts as one of our 4. Because we're counting kind of an Inya. Looks like a, in fact, if you go all the way out here, it's a big Inya. Like the tilde over the top of the Spanish N. So let's count from this star. 1, 2, and then there's a little one there. Now, then you have a jump, and there are 2 closer there. So, starting from this one, here's our Inya. Looks like, starting from the Capella side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe we can see 10 stars in that Inya. 1, 2, 3, 4. So it'd probably be the 4th one that we see from the Capella side. I find this so interesting that we can zoom in on this like you can in binoculars. I believe we are seeing the comet right there. Or maybe there. There's so much noise in this shot. I don't know if we increase this to, let's decrease the gain here for a second. Let's decrease this to maybe 200 and let's increase our time to 5 seconds. And let's just see what we get here. Maybe 6 seconds. So what we're using now is a monochrome camera that's actually on top of the scope, and it's not pointing through a telescope at all. Wow, look at that. Now we're seeing it more clearly, aren't we? So here's our thing that looks like an Inya on top of an N. 1, 2, 3, 4, 5-ish. There's a little, see this little arc? And then here are 2 stars. So on Stellarium, let's look for this arc and then 2 stars. So we're looking for this arc. I'm gonna put my, I can't get rid of the RASA, can I? Maybe, no, I can't get rid of the telescope symbol, but we can zoom in a little more. Here's that arc, and then here are the 2 stars. So in that arc, it is the 3rd star from the Capella side. So let's get oriented again. Here's our Inya. Here's the arc. There are the 2 stars. That is the comet right there. So we can even pick this out with an ASI-178 monochrome camera that's not looking through a scope. Let me show you what this camera looks like. It's that red little monochrome camera on the top of the scope you see there in the picture. And look at the drawing on the left. You can see that little outrigger that holds it up on top of the RASA. And then on the picture on the right, The red camera has that dew strap around it just to generate a little heat so that lens doesn't do over. That's funny. So the dew doesn't form on that lens because that's just exposed. There's no, what would you call it, dew guard on it at all. That's just pure camera. And I think it's amazing. We can pick this comet out of a string of stars. 1, 2, 3, right there, with certainty now. With certainty, right there. Now let's go back over here. 1, 2, 3, C22E3, Z2F. That little third dot would not be there if it weren't for the comet. 1, 2, 3, right there it is. Oh, that's fascinating, isn't it? Let me see what you guys are saying. C2022E3 ZTF. Mike, what causes a comet to be green or not green? I tell you, Mike, I think it's the oxygen that's burning off. It's the cyanide kind of chemistry in there that's burning off. The sun is heating it up and sublimating. This is one of the places in the universe where you can see sublimation happening. And when the sun cooks it with its ultraviolet rays, the chemistry that's produced is like a green mist glow that's lit up by the sun. That's my understanding. And one lateralus, one, hello, thanks for waving there, Azra. Ross 11 is 620, not 420. Thank you, Azra. I always get that mixed up. I'm kind of digging those wispy clouds. One lateralus, one. Auto stretch on histogram. Yeah, I did that a while ago and it didn't seem to make much difference. Yeah, it's not making much difference on this 178. Okay, I think we've kind of gotten an idea. Let's bring this back out to 100 to full view. Okay. And that's really why we have this camera, so that we can kind of stay connected to the night sky. But it is fun, isn't it? This is Orion over here. See the 3 belt stars? And then the sword comes down here. And Cassiopeia here. The Big Dipper is always on the opposite side of the North Celestial Pole from Cassiopeia. These are despicable clouds that are making things misty. Let's go back over to the view that we have real time in the ASI2600MC Pro. Here goes some kind of a satellite down here in that image. These views are about 10 seconds in length. And I don't know if we back off here. This view is about, what? Didn't we figure out 2 degrees wide by 1 1/4 degree high. So 2 degrees wide by 1 1/4 degree high. So that's probably one of those stars. I don't know if it is because this is pretty tight view. Well, it's a very interesting shot with these neighbor little pointer stars being this close. So you can tell your kids that you saw a heavenly body that came from out in the Oort cloud and flew in and dodged past the Earth a mere 26 million miles away, 27 million miles away, and you saw it live. How about that? So we've got about 16 on the channel right now. We hit a high last night. At one point we had, I think, 100 real time. But I don't know if you noticed, last night's view of the comet has already hit 2,400 people. Tell you what, the media, they do us a great favor. They act like this is something that's just whizzing by the Earth, and they show this animated background to make it look interesting, which is deceptive. And I think people expect that this comet is going to look like a slow-moving, meteor. And they're going to expect to see this tail from a slow-moving meteor. And I think people are expecting they're going to have to get up at a certain time. And at one point in the night, if they stayed up, they would see this kind of streaking by. When in reality, it is moving relative to the stars just at a snail's pace, So, okay, so at this point, I don't know if this means that we hit our meridian or what, but we definitely stopped tracking. So let's go figure that out. Something caused us to stop tracking. Let's look at a picture of the scope. Yeah, we're all the way over, aren't we? So I'll tell you what let's do. Let's go back over here to our scope control, and let's go back to our 0 position. Go to 0 position. So the scope will now realign itself to the North Star. It'll get all set again. So there we are with the weights down position. Andy says, revert back to your chemistry class. Metals and gases emit different colors when heated. That's right. And our friend from last night, I don't know how to pronounce your name. If you can give us a phonetic pronunciation of your name, that would be great. I think it's cooler that it's the opposite of that. Laugh out loud. Yeah, that's a good idea. Okay, that's probably the North Star right there, smack in the middle. It's probably Polaris. So now we're aligned. Now we'll try to enable tracking again. And it did. So we basically got so far over in that equatorial tipped position that it couldn't go any farther. And I've got to check my settings. I thought I had it set so it would automatically do a meridian flip, but I must not have it set for a meridian flip. I must just have it set so that it just simply stops and tracking goes off. I think that's true because it didn't make any sense in EAA for it to do a meridian flip while you were live stacking, did it? Because that wouldn't help the live stack at all if you pan through the whole night sky. All right, so I'll take a vote here. What do you guys want to do? We could go back to the comet at this point and see the comet again, or we could resume the Herschel 400 and maybe look at clusters. That's one thing we'd be able to see well tonight, are clusters. We could try a galaxy or two, and we could even go look and see if we can pick out a diffuse nebula. But I don't know if those things are going to be very visible in a 98% moonlight. But we could try them. We've got, in the Herschel 400, we've got at least, I'm looking at least a half dozen or a dozen galaxies that we could go look at. And several open clusters, maybe at least that many open clusters. A couple of diffuse nebula. What do you guys want to do? Because I'll go either way. We are at 9:39, so at 40 minutes have elapsed. We have an hour and 20 minutes left. We could zoom through and see how many of the Herschel 400 targets we could get. Clusters, Mike says. Mike was the first on. And you know what? Mike has invested as a patron of the arts. And I don't know if you guys have checked this out, but while we're at a stopping point here, I'm just going to go find our browser. Where did our browser? There we go. I'm going to find our browser and open up a browser window to Patreon at Emerald Hill Skies. You can go there. It's Patreon at Emerald Hill Skies. I'm going to put it in the little title at the bottom. Let's see. Title on screen. There we go. Patreon, spelled with an EON at the end, .com at Emerald Hill Skies. Mike is one of our true patrons. And the idea here is that you just become a patron of the arts. And from this money, what we do is we do checks made out to charities. And tonight's check is going to Afghanistan. And this goes to help people that are over there in the cold in Kabul. It's at least as cold in Kabul tonight as it is here. Another thing you can do is go to the actual Emerald Hills YouTube channel, and you can see it's youtube.com at Emerald Hill Skies, or just search search YouTube for Emerald Hill Skies, and in the YouTube channel, you can go to Store. And you'll see all these different mugs and bags and stickers and shirts. And click on any of these if you click on any of these little from Spreadshop logos, it takes you to the Emerald Hill Skies Spreadshop. Would you rather shop the American side? I guess. You can go to organic products, you can go to men's hoodies, for example, and search for just the right color. You can change the colors. You can get a yellow hoodie. Who would want a yellow hoodie? Maybe if you worked on the state road, I'm sorry. If there's a white logo, then you can go with different colors of dark. And these are different prices, and any of the money that comes back to us, again, we put it toward refugees in places like the Somali region of Ethiopia, the Somali region of Kenya, Ukrainians who are in the middle of a struggle trying to stay alive. So that's what that's all about, and you can go to that. Again, to get there, you just go to Emerald Hill Skies on YouTube. So just search all one word, Emerald Hill Skies, and it'll take you right there. All right, so let's do clusters. Oh, yeah, and Stu says you can always put Super Chat, and the way you do that is if you're looking at the live stream tonight, and can I just do this? I mean, will this mess things up if I go here and where is it? If I, here, see where these comments are. Hello, everyone. Right here, there's a smiley you can do, and right there is a Super Chat. And you could just set the amount that you want. And you could do, you know, $3 or $5 or whatever you want to do. You could do that right now if you like. And also, while you're here, if you would please, would you subscribe to the channel and click the thumbs up button if you would please. That would be awesome if you wouldn't mind doing that. Okay, I'm going to stop this just so it doesn't represent another, you know, stream here going in and out of this office. We are inside the office. The observatory is way out there at 200 feet away, and we are inside the office 200 feet to the south of this observatory. In fact, while we go, hey Wayne, good to have you from Chester, West Virginia. Andy says hit the like button. Let's see, let's go hit a cluster. There's our last view of the North Star. Let's go hit a cluster. I'm going to bring our observing software here, and right there is the last view of the North Star. Let's go, well, let's just test our luck and see, will this diffuse nebula show up in a 98% moon? I doubt it, but it is Herschel 20-4. So what we're going to do, we're already connected the telescope on this particular telescope control. Yeah, we're connected already. So we're going to go right-click slew to this diffuse nebula NGC 2185. So we're going to go to NGC 2185 and from the Herschel list. And this is a diffuse nebula from the Herschel list. It's been a while since we've focused on the Herschel list. Oh my goodness, it looks like it's aiming right at the moon. Let's look at our sky cam. Yeah, there's the moon. So is this going to show up? We're going to find out. NGC 2185. So here we're going to go in our SharpCap software now. We're going to go to our sequencer and we're going to say prep for imaging. Prep for imaging only. Well, if we're going to do that, we might as well do next target. And it should be NGC 2185, and the mount is settled. Now it's going to do that, plate solving, Witchy-Crone. At any point I'm wondering what's the difference between a meteor and a comet. This is Barbara. Barbara, that's a great question, and this is a perfect time to ask it because you see we're waiting on the telescope to align with the sky here. A meteor is a true rock, and most people think that meteors formed because, let's say, some kind of an asteroid or planetoid or something broke up, and when it broke up, it formed hundreds or thousands of different rocks, and those rocks are solid. It's not a ball of ice or a ball of particles or a ball of little rocks or anything. A meteor is a true rock, and it is like a flurry of rocks, like you'd pick up a handful of gravel and throw it at the Earth, and when the Earth moves through that orbiting stack of rocks, we're fortunate to have an atmosphere because the atmosphere burns those rocks up with the friction. And when we see a meteor, it really isn't being lit up by its own fuel. It's being lit up by the atmosphere playing tricks on it. The atmosphere is so much friction that it basically starts the meteor to disintegrate. And as it disintegrates, it is burning up in the atmosphere and very rarely hits the ground. When it does, we call it a meteorite. Once it hits the ground, it's a boloid or a meteorite. A comet is a collection of ice and gases and like a snowball, basically. Except imagine if you made your snowman in the yard and you did it beside the driveway and you got some gravel in with the snow. So the comet has gravel from the driveway and a bunch of snow and chemistry in it, and when it gets close to the sun lights it up because of the sun's ultraviolet rays and the sun's heat and energy. The comet's not entering the Earth's atmosphere, so it's not burning up because of the atmosphere. The comet appears to light up because the sun is cooking it and cooking off all these gases. And the halo we saw of C 2022 E3 ZTF, the halo we saw was the sun cooking off all those galaxies. I hope that helps, Barbara. Thanks for asking that so we could have that long explanation. Stu said it a lot faster. Comets are made of ice and dust. Asteroids are made of rock. That's really all I had to say. Thanks, Stu and Doug. Stu, a meteoroid is a small piece of an asteroid or comet. A meteor is a streak of light in the sky that appears when a meteoroid burns up upon entering Earth's atmosphere. Well done. Witchy-Crone said, Stu, I prefer Doug's explanation over Google's. You're nice. Okay, let's see if we can make some sense out of this drawing here. Wow, it's really kind of lit up, isn't it? This is the moonlight that we're seeing. That's not a bad color balance, so let's bring our darks over and make that somewhere around right there, and then let's bring the mids back up and see if we can. We're just stacking for 2 minutes here, but where is this diffuse glow that we're supposed to see? So what we're going to do now is we're going to ask our so this is NGC 2185. NGC 2185. So I guess this is just this is very close to the Angel Nebula, and it's just a diffuse section of the night sky being lit up by these stars. You can see it's almost like a cluster of stars. 1, 2, 3, 4, 5, 6, maybe even 7. That's 2183 over there, but this NGC 2185, I have to wonder if that is it's a reflection nebula, and its magnitude 13 basically. That's going to be very dim, isn't it? And we're seeing several of these stars, but whether or not we'll see this reflection nebula with the moon. Let's see how far we are away from the moon here. The moon is right here. So I always say within 20 degrees of the moon, it's pretty useless. 20 degrees, so this should be our little, yeah, 21, is this where we are, right here? Right there, I guess. So that's about, our numbers up there, 41 degrees. So this should show, but boy, that's faint, isn't it? Magnitude, let's see, 2185. Magnitude 13. Surface brightness magnitude 14. Boy, it's an inky black sky there, isn't it? No clouds here tonight. Let's see if we can light up some of this nebula here. You know what, I think we might start to see it now right here. Look at that cloudy part around that star. Let's zoom in on that. Yeah, that's starting to be a little bit of our nebula. Now this background stuff, that's all just moon and light pollution, but now you can start to see that is the nebula starting to form up right there. Maybe a little bit here as well. So this is a diffuse nebula, and it is H20-4. So I'm going to look this up. H20-4 NGC 2185. In Stephen James O'Meara's book, '2185. Well, he doesn't give you the page number in that index. That's crazy, isn't it? NGC 2185. Here's another index. 2185. We've got these separated. Here we go. Page 53. Page 53. NGC 2185. Yeah, it's just a little scratchy looking nebula right there around those stars. It says it's an extremely small reflection nebula, nearly 1 degree west of Gamma Monocerotis. It's associated with several other patches of nebulosity that extend about 1 degree to the west and southwest of NGC 2185. If you know where to look, you can see it in a smaller telescope, but think small. Be prepared to look for a fuzzy star right here. This fuzzy star, that's the nebula that we're looking for. It will be very difficult to see under light polluted skies. And that's all he says. He says, so if you can see his photo, yeah, he's even got this arc. See that little arc of 3 stars? This is the nebula that we're looking for right there. Not much to it, is there? Let's see if we can brighten it up a little more. No, we get right into the light pollution if we brighten it up more. But that's just 8 minutes. I think if we stayed longer, it would brighten up more with more time. But let's go ahead and add an observation. I want to make this session add an observing session. 9, let's make this 9 o'clock. 9:00 to 11:00. And this is something like, I'll look this up later, something like session 105, but I'll have to, and we had a 98% moon. Loved the views of C 2022 E3 ZTF. Okay, so that's the session. Now in the notes for this object, we're going to say this is a super tiny reflection nebula, basically surrounding one star and some accompanying space dust. That's what it looks like. Not life-changing, but nevertheless a cool target to train our muscle memory. That's what I look at. That's what I look at times like this, is can we make ourselves see an object from the Herschel 400 on a moonlit night when the moon is at 98%. And sure enough, through EAA, and only through EAA, we can. That's the diffusion nebula that we're looking at. So again, over in our stellarium, it's this stuff. And there's the star. Now, is that the meridian? Wow, we're in the meridian again. We're going to get hit by the meridian again. Well, maybe we've got about 10 degrees, so let's hurry up and go to our next object. This is a galaxy, H1371. Oh, we're live stacking. We better go to next target. And that way we'll stop live stacking. And it's H1371. Slew to it. And it's NGC 2859. NGC 2859, and that's a galaxy. And this is in the a galaxy in, what is L minor? What is that? What is L minor? NGC 2859. 2859. See what you guys are saying here. I saw Halley's Comet in '98. It was beautiful. And Mike clarified, do you mean 1985? And Stu said, well, Hale Bob was 1998. And Stu says, oh yes, Hale Bob was wonderful. Stu says Hale Bob was visible with naked eye for 18 months. Wow. Witchy Crone laughing. Yep, just look that up. That makes sense because I remember seeing it here in Wisconsin in December. Thanks for that. That's Barbara. Donald Ray. Good to have you here, Donald. I remember that cult thought that was a spacecraft traveling behind Hale Bob. And Barbara laughed. Kevin Cole, great to see you here. Another one of our patrons from Patreon site. What star is lighting it up since the reflection nebula? Okay, let's go look at that because we haven't moved. It would be one of these stars right here. Whoops, I just hit the wrong button. Right. Would be one of these stars right here. And they are so nondescript that I don't even think they're identified, Kevin. Oh, there it says star. And it's not even got a number that's marked here. So it's a 16th magnitude unnamed star, but the nebula around it is named. How about that? Good question, Kevin. Let's see. When I saw it, I said, Donald Ray, nice. Barbara, first and only time I saw that. Hope you took some pictures. At that time, I was celebrating a marriage. Oh, I'm so sorry, Witchy Crone, that he passed. Won't forget that site, though. Angela, condolences. Good job, Angela. Donald, I saw it at work, didn't even think about a camera. Thank you, that's sweet. Kevin Cole. Leo Minor, thank you so very much. Kevin, watching my back. Leo Minor. Okay, so now let's go back to the screen and let's, well, this is already live stacking for us. It's doing its job. While we were talking, it did this little script that we have written. So let's pull our darks in to right about here and pull our mids here, and I hope we can see this galaxy. My goodness. So this is NGC 2859. What we're going to do here now is we're going to go to our, this is a pretty cool feature. Look how when we, by the way, I'm going to back this off so we get a little better view of the night sky. But this is a cool feature. When we go to our targeting software, we use Deep Sky Planner 8, and we right click, we can say show chart, and watch what happens. It instantly adjusts the chart to see the galaxy. So it's NGC 2859. NGC 2859. Oh yeah, look, there it is. NGC 2859. So it's a magnitude 11, a little bit dimmer than magnitude 11, surface brightness of 12, and it says it's only 1 arc minute wide and 1 arc minute high. It's 94 million light years away. 94 million light years. So let's go back over here and see what we can see. Oh wait, first let's get our bearings. Let's put our camera on here so we can see the RASA frame field of view. So this shows us roughly the RASA field of view. So we're going to see a rainbow or an arc of stars like a satellite dish. And this galaxy is going to be right in the middle of where like a receiver would be if it were a very shallow receiver. Let's go back to this. Oh, here's our satellite dish. And our galaxy is supposed to be right here in the middle. What do you make of this, guys? After 3 minutes, we're not seeing a thing, are we? Let's, yeah, let's try. There we go. So we had to reset our display histogram, Azray. All right, now let's do, we don't need to color balance again, but that definitely helped us with our display, didn't it? Now we're going to bring up our mids. This is a tiny, tiny galaxy. See, here's our satellite dish, and this is where the receiver would be if it were right in the middle of the, what would you call that, a palabra? Is that right? Palabra? Parabola. It's a parabola, and right here at the middle of the parabola is this little galaxy. It's so tiny. My goodness, how did Herschel ever distinguish this? He was observing from the suburbs of Paris, for Pete's sake. How could he tell that was a galaxy? Tell you what, we've got to hand it to this guy. And he didn't have the benefit of live stacking. He was observing visually with an eyepiece. This guy must have been an amazing astronomer. Let's see. Quick, someone name it. Have your name written in the stars. Wichikron. Oh, Andy, what's the best candy to eat while looking at the stars? Milky Way bars. That's good, Andy. Angela, yeah, that's a good one. Wichikron smiled and laughed. Angela, Stu, or Mars bars if you're British. Nice. Azray, try the auto stretch. Yeah, you were telling me. You meant down here. I think we're good now on our stretch down here. The Earth is 62 million light years away from this. That's pretty far. Angela, another good one, Stu. Wichikron missed that. Great one. Kevin, suburbs of Paris. In what year? It would have been like 1870s, I think, Kevin, but we'll look that up. Azray says dark skies. They weren't dark, but they were darker than they are in Paris now. You're right. This is NGC 2859. So we're going to go back to the index. Unfortunately, with the Herschel 400, you have to go back to the index. NGC 2859, because he doesn't have the big band of numbers. It's on page 79. He doesn't have the big band of numbers at the top in the Herschel 400. It says 2859. It's a small and dim barred spiral galaxy. Okay, we might just barely be starting to see the bar. I believe we are, barely. Starting to see the bar across. And he tells the location. It's a difficult object for small telescopes and requires a dark sky and averted vision. He says, in small or medium-sized telescopes, it's not readily visible. I could just barely detect it, he says. And with averted vision at 72 power, he talks about power. He says, with some attention, a very subtle core becomes apparent. Well, we've definitely got the core. It's called the UFO galaxy. That's the nickname. It's the brightest of some 24 galaxies that populate Lynx. Wait, oh, that's the next object, sorry. Well, 2859, he only has one paragraph about it. He basically just says, this is difficult. And then now we've got to figure out for Kevin's question. And Omira doesn't tell us, so we're going to find out 2859 in what year, NGC 2859, in what year did Herschel discover? March the 28th. I was off by about 100 years, Kevin. That's terrible. 1786. 1786. He had his own homemade 18.7-inch f12.8. I'm so ashamed. Imagine if your telescope is f12.8. Oh, and at this point he wasn't in Paris. Sorry, that's Charles Messier. He was in Slough, England. Boy, I got to get my stuff together. S-L-O-U-G-H, Slough, England. So this is what we're looking at here. It's barely got a glow in the middle and barely got a secondary glow around it. So let's go back. Yeah, so we're seeing definitely the glow around it is starting to stack. And by the way, this picture, this was let's see, 120 plus 230, 350 minutes LRGB, 350-minute exposure. How long is that? 6 hours. It was a 6-hour exposure. So we're going 8 minutes, and this is what we have so far. But we can tell that's some kind of a patch of something, can't we? It's not going to win any awards, but it is definitely, for 8 minutes, it's pretty amazing. Mike says, Paris or London? Oh, yeah. Microsoft.NET framework. An error. If you can ignore this there and attempt to continue. I'm going to attempt to continue. Who knows which application that is? We're using a beta of SharpCap here, so it could very well be SharpCap. So why don't we get a picture of this, and let's do our observation. And this is a 1 minute, 1 arc minute wide patch Did we say 1 arc minutes? 2 by 1. 2 arc minutes by 1. So 2 by 1 arc minute wide patch of fuzzy light. We could barely make out the bar of the barred galaxy at 10 minutes exposure. Wouldn't win any awards, but we definitely found the target. So there you go. NGC 2859, Galaxy in Leo Minor. Cool. We've been speculating that most of what he discovered was actually found by his sister. That's right. Caroline was his #1 partner. Kevin says incredible. You're right. And it was a hand-ground lens, homemade, right? Lovely sounding place. Slough. You're right. Hubble has a good one on Wikipedia. Let's go over and see that real quick. Is that Stu? Yeah, Stu is definitely our scout. So we're going to go back here and go to Wikipedia. Oh, you're right. That is good. This is a target that befits the Hubble. But you know, I got to say, to me, that looks really noisy, doesn't it? Hubble had this thing turned with the reds way up. Look at all that noise. But maybe that's what the nebula looks like. Maybe the nebula just looks like noise. Okay, let's memorize that noisy look. And there's that outer halo. Now let's go back to our real view. It looks like a noisy fuzzy patch, all right. We're a little bit beyond the optical limits of our RASA 11. That's the optical limit of our RASA 11. This is what you considered digital zoom on your little handheld pocket camera from 5 years ago. If it had a digital zoom, or even on your cell phone, digital zoom, that's what this is. Cool. Slough, just west of London, currently Bortle Class 7. Bet it was slightly better in the 1780s. You're right, Kevin. Stu, bet the sewer system wasn't better. And Kevin laughed. Stu, the central supermassive black hole is estimated 105 million times the mass of the sun. Jumping gigawatts, that's a big black hole. All right, so we're going to go to our next target here. We're going to say next target, and looks like we can pick another galaxy, or we can do a cluster. All these, let's run this again. And you can see we have some other targets now we can pick. Here's a galaxy in Ursa Major. Let's go to that. So we're going to slew to it. And it's NGC 2950. NGC 2950. A galaxy in Ursa Major. NGC 2950. Let's see. It's the mount is settled, yes. And now it's going to, in the meantime, we'll go over and take a look at it in our star chart. So again, we're going to back off of this so we can kind of see where we are in the sky with the constellations. There's Leo. See the head of Leo? It's one of the few constellations that actually looks like what it's supposed to be. Doesn't that look like a lion? There's the head of the lion. It's the tail. Cool, huh? So we're going to say show chart, and then it's going to So we're in Ursa Major. Here's the bowl. So if you could sort of imagine the handle going up and use the two end bowl stars as pointers, then roughly it would point right and bisect. It would bisect that, what is that called, a chord? I forget. It would bisect that, and it would come up here just past this star. And we don't deal with these stars too often when we talk about Ursa Major. We're used to the Big Dipper. But the Ursa Major still continues, and that's where we're looking. And this galaxy is a tiny thing. It's a magnitude 12, and it's 1 arc minute and a half by 1 arc minute. It's supposed to be 70 million light years away, 70 million light years, and 1 arc minute wide. Herschel liked these narrow targets, didn't he? Okay, so looks like our crests are still doing okay on our color bar. Let's reset our display histogram again, yeah. And let's go just a little left of center. And then bring up the mids. And I see it right there in the middle, but man, it is sure dim. I mean small, sure tiny. Wow, it looks like a little Saturn, a little tiny Saturn there, I think. We'll let it work there for a minute, and we'll go see where we're looking here. So again, bisecting those last two stars. Catch up over here. NGC 2950, discovered in 1790. Kevin, another barred lenticular, similar to 2859 that we just looked at. Stu, we're spoiled in the Southern Hemisphere. Our most prominent constellation is the Southern Cross, which totally looks like a cross. And Kevin smiled at that. Yeah, we have a bunch of constellations that don't look anything like what they're supposed to be, and it's kind of embarrassing. I mean, you might look at a pair of two stars, and those two stars are now, bam, a rabbit. I mean, that's how bad it gets up here. So Stu, you can be glad with what you've got down there. Isn't it magical that Stu can be with us? And Stu, I think if I remember right, you're in New Zealand, and is it near Auckland? So did you get flooding, Stu? And if so, we are very sorry. We hope it didn't flood your house. Look at this little arc here, a little arc of stars right above this galaxy. Let's go look this up. It's 2950. Boy, I should put a bookmark in the proper NGC listing, because I have to go thumb through the index every time to find the NGC listing. 2950 is on page 43. Okay, says that 2950. Oh, it definitely shows that that little arc above it. It's a very small but very condensed barred spiral galaxy, a little more than 1 degree west of that star, Upsilon Ursa Majoris. He tells how to find it, then he says, it's a very small star-like object that swells slightly with averted vision. If you go to 72 power. See, power doesn't really mean as much to us because we're doing EAA with a camera, not a lens through an eyepiece. Very bright nucleus, yep. Larger instruments make the galaxy appear brighter but do little else to show detail. Yep. He says the next target is nearby, so we could go to 3079 here. You can see if it's in our field of view. let's just look here in our star chart, back off a little bit, and find NGC 3079. Oh my goodness, you're right. It's right there. The Phantom Frisbee galaxy. The Phantom Frisbee. Huh. I wonder if we've already observed that. No, 3079, if that's it. Yeah. So I wonder if we can see this in our same field of view. Let's back off, and sure enough, oh no, look, there's the RASA field of view. It's not going to be in the same field of view as this. Okay, so let's snap a picture of this at 4 minutes. I think we're getting the idea, huh? It looks like Saturn. It reminds me of Saturn. See what you guys said. Is everything identified up there? Do some disappear or die out and others come? You know, every once in a while you'll get a supernova explosion, and that'll make that star essentially explode for a while, and then maybe decades later it'll die out. But for the most part, everything stays the same. When it comes to stars and galaxies, nebulae, they all stay the same. It's only going to be the occasional comet, planet, asteroid that are moving around. Otherwise, it's going to stay the same. I have a coworker, Niall, that lives in New Zealand. Do you know him? I don't. Oh, you're asking you're asking Stu if you know him. Stu, we got lots of rain, but it didn't flood. Well, we're glad, Stu. One of the neighbor's house got slipped on, though. 3 kids in the house at a time, all rescued by the neighbors, thankfully. Wow, we're glad, Stu. Asray, it's called a vivid imagination. Maybe that's the 2 stars making a rabbit. I think that's what you're responding to, Asray. Stu says, things come and go, but the time frame is so extreme that our little speck lives don't really know. So that's a better way to put it, Stu. You're right. In the time space of our observing, they don't disappear. You're right. Thanks for clarifying, Stu. Okay, so let's go to our next target, which is going to be in GC. Did we do an observation of this? We didn't. Or did we? 2950. We did not. So let's write a quick observation of this. We said looked a bit like Saturn to us on our 98% moonlit night. Amazing that we could make it out at all, only through EAA. We could see the glow, but since it was just 1 arc minute in extent, whatever you're supposed to say there, not much else. Bright core. Okay, so when we click OK, then that object disappears from our list, and we can go try to find other objects. So 3079 is the one that's nearby. Let's try to go there. Slew 2. There's not much to see in terms of movement. 3079. And now it looks like it's settled. See. Let's go back to our planetarium and look at this one more time. Wow, I wish we had a super Hubble. It's a cool looking phantom Frisbee galaxy, isn't it? Oh, so see, the RASA was tuning up right there in front of our very eyes. Oops, sorry, I didn't have you on the screen. Our RASA was tuning up with its plate solving. So it just put the galaxy in the middle. So here's this phantom Frisbee galaxy. It's kind of cool, isn't it? Magnitude 10. Doesn't tell its size or its distance. But it does look pretty cool. Look at these, kind of like, what? Maybe it looks like a cross, these 4 stars with the galaxy being one of the edges of the plus sign. That looks like another galaxy might be right out there, huh? Let's go look and see what we got. Wow. It looks good already. Wow, that's cool, isn't it? And just says, beautiful to know. I think I just see what I think I see. We chose clusters, Doug. Okay, clusters coming up, Mike. Sorry. Thanks for the new words, Stu. What is that? Hubble got a beauty of this one. Yeah, I agree. So beautiful. Angela, yes, indeed. All right, let's see if we can make the live view look any better. We're going to put the darks right there, and then we're going to let this cook a little bit. A lot of what you see there now is like, it looks sort of like confetti, doesn't it? And that's atmospheric noise and the moon. Let's figure out where the moon is here. We're still in the Big Dipper. There's the moon. Now let's get this angle of extent again. I like doing this because it gives us an idea of how much confetti we're going to see. 37 degrees. That's getting closer to the moon. But we should be able to do this at 37. I just don't like to do less than 20 with the moon this bright. You know, with the EAA, you can see a lot of things in a night sky, even though you've got a full moon. It's just you got to stay away from 20 degrees of that full moon because everything's going to be wasted within the final 20. Look at that. Isn't that beautiful? Let's drop our mids a little, see if we can get rid of some of that confetti. We'll make the sky a little bit darker, and that'll cause more contrast for the object. Let's zoom in on the object now. Still got some noise. Again, that's moonlight. Some of that's not going to come out. It's just going to be what it is because of what we're seeing there is the real glow of the moon. And we're trying to blank out that glow by establishing a new baseline. But when we establish the new baseline, and we're saying, consider this the color black, because we don't want to see this moonlight. But when we say, consider this the color black, it's blackening out some of the light of the image. So, you know, you can't win for losing sometimes with that moon glow. And then you add in Bortle 6 skies as well. Pareidolia is the human ability to see shapes or make pictures out of randomness. Wow, Stu, that's awesome. I'm going to have to learn this word, pareidolia. Pareidolia. Thank you, Azrae. 50 million light years away. Man, can you imagine that 50 million years ago, there was a bunch of burning of these stars and gases and all the different objects in this galaxy, and they were burning, emitting light, and they sent out light in every direction. And along the way, as that light began to emanate, as it grew farther and farther away, it also grew fainter. And the particles and waves, the packets you could call them, the packets of light, grew farther apart. So imagine how much farther apart they are at 50 million light years. We have an 11-inch telescope out there, and tonight, that 11-inch telescope captured some of those particles coming from this galaxy. And what you're seeing now is our telescope's attempt to register those photons, those packets of light that are landing on our mirror, and align them together and make it look like some semblance of what this object looked like 50 million years ago as we perceive time and space I just find this radical. I mean, it's amazing that we're looking back in a kind of a time machine here. And it's actually doing a fairly decent job considering the moon is just 39 degrees away and it's full. Crazy. Now if I get this black threshold too far, then it says, oh, wait a second, are you wanting all that moonlight to be part of your black? And we say, no, we don't want that moonlight to be part of our black. And it says, well, okay, but I'm going to lose some of your object. Okay, that's 5 minutes. It's amazing that after 5 minutes we can see that. Look how it extends a little bit more on this side. And look at that bright star. That's probably a foreground star there. But look at it's thicker over here. Let's go back to our planetarium software and zoom in. Sure enough, it's thicker over here. And there's that bright star. Doesn't say how far that star away is, but that is definitely a foreground star. The Phantom Frisbee Galaxy. This looks like a galaxy here. So that's up and to the left. Let's see if we can find that. Yep, right there it is. Up and to the left. Fascinating. Okay, let's do our observation of this. This is 3079. I'm going to say, amazing that we could make out the thickness of the right side in 98% moonlight. Saw a foreground star on the left and a companion galaxy upper right. We don't know what that companion galaxy is. It is not named in Stellarium. That was H. Have I not fixed my title? Sorry about that. I'm asleep on the job. This should have been 3079, 3079, a galaxy and still in Ursa Major, right? And the Phantom Frisbee. Did we read about 3079? It lies about, tells where it is. Somewhat difficult to see. It's long and narrow, fairly faint. Light pollution will certainly affect the visibility. Tells how to find it. It's a barred spiral. Not sure what the bar is, other than a place to get drinks. 5-minute long streak of light oriented north to south, tricentering. He says it's a very pretty sight. That's all he says. Not a lot about this. Okay. Azra is saying reset the display histogram. Ah, look at this. Azra, you're on the ball. Thank you. This is why I think astronomy is a team sport. Look how much we can bring the blacks over and pick up all that faint stuff. And I'll bring these mids in. That's so much better. Azray, thanks. We're at 200% now. That's 130, 100. That's 100% of our RASA's view. The RASA is a fairly wide field scope. 2 degrees wide is considered really wide for deep sky observation, especially when you're looking at an object that is 1 to 2 arc minutes long. we have a telescope that can see 2 degrees width, and we're looking at something that's the size of a pinhole. But it's working, isn't it? But I like the RASA because it has that open f-stop, f2.2, so it drinks in light quickly. So something like that. Okay, we're going to save this. And thank you so much, Azray, for reminding us of that. Astronomy is a team sport. Never not amazing the photons have traveled 50 million light years, just bounced off your mirror. I know, and I always feel bad, Kevin, because I think, wow, we just selfishly absorbed all those. But then I was observing one night, and one of the friends that was with me that night said, Doug, if it hadn't hit your mirror, it would have hit the dirt, for Pete's sake. So don't feel bad at all. I realized, okay, you're right. Frank Rossetti. Yeah, Frank was telling me to reset the display histogram too. You know, I thought I had that programmed into my script, but obviously I don't. I must be mistaken. Where do you guys want to go now? An open cluster, I think, by popular demand in C major. What would that be? C major? That goes, oh, just kidding. Whatever C major is. Corona major? No. Cactus major? What does C stand for? Anyway, we're going to slew to this, oh, it's called Caroline's cluster. Wow, that's cool. She finally got credit for something. This is Caroline's cluster. It doesn't have an NGC number. So we're going to put here Caroline's cluster. We're just going to call it that. And man, bam, we're right there, huh? It like skates to a stop real quick. Put its brakes on. Okay, so it looks like those have settled, right? Okay, there we go. And Frank, good to have you here, man. Upstate New York, I would say you're looking at probably, what are we here? We're currently at 14.7 degrees out there on top of the telescope. That's where the thermostat or the thermometer is, in that blue box, right there beside that blue box. It's right there beside the blue box. It's 14.7. So I'm thinking up there where you are in Schenectady or wherever you are up there, Frank. I'm thinking that you're probably looking at, see, 8 degrees. What do you got, Frank? Witchcrone. The whole thing is awesome. Wow. Stu, what we see happened 50 million years ago, everything could have changed and we'll never know for millions of years. Right. Witchy Crone says, oh my stars, no pun intended. Stu, love it when Doug takes his time machine out for a spin and appreciate being able to come along for the ride. Stu, you're great. Witchy Crone, my first time live here. I feel blessed. You're so nice. Thanks for the encouragement. Kevin's going to knock off for the night. Kevin, thanks for being here. We'll send you these high-res photos because you have the highest level of Patreon that there is. So we'll send you these Patreon high-res pictures. You get access to them. It's like you're the only one that gets those high-res photos. I'm going to do this before I forget. Restretch the... Thank you. Is Kevin saying goodbye? Yeah, Kevin had to say good night or good day. Andy, can we go into it? Into the time machine. I think that's what you're saying, Andy. Stu, a barred spiral is a spiral galaxy with a central bar-shaped structure composed of stars, but we can't see from this angle. Yeah, that's what I was saying. I was having a hard time. Oh my goodness, look at this. This is beautiful. Caroline, you did things up right. I think I've observed this before. I think I remember seeing this cluster. Because I remember what a rich star field that is in the background. Let's make that night sky go a little bit darker, so we see a little bit more, not that much, a little bit more contrast. Man, I'm telling you, is that not beautiful or what? I mean, just back off of that for a second and count those stars. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. 32 stars in that one little patch, and that's not even the cluster. Man. Is that spectacular or what? Thank you, Lord, for making all those pinpoints of light. Every one of those is a fiery furnace that would remind us of our own sun. And there are 1,000 suns in that picture, I bet. It's just nothing short of spectacular to see that kind of lace of 1,000 points of light. And then right in the middle of it is Caroline's cluster. Now this is where you can really appreciate the 2 degree field of view of a RASA. A lot of my friends have these real, soda straw kind of things, but I just like every once in a while being able to see this. I mean, you just look at that and it feels still, It feels tranquil. I'm going to go up here and see if our music is playing. And if our music is playing, I'm just going to stop it just for a second. That's amazing. That's amazing. Well, I don't know what to say about this. It's just so beautiful. What are you guys saying? Hello from rainy Portland. Pun Jedi. Azray, not me. Frank said we said that. Oh, okay. Frank, thanks for rescuing us. He's going to keep blaming you, though, as Stu said. Mike, we should have a bar hopping night. Barred spirals only. Let's do it, Mike. That's awesome. It's the only time I'm going to go to bars. Angel, that's so cool. Canis Major. We need to fix our title for Pete's sake. This is Caroline's cluster. Caroline's cluster, a tapestry of stars in, where are we? Something, what was C again, remind me? We must not be looking at it in our, let's show chart. Canis, that's right. And Canis Major. You can see in the This is the planetarium software. And you can just see the tapestry of stars in this part of the Milky Way. It's just amazing, isn't it? So what we're doing is we're looking through our disk. By the way, I always like it when this happens. You can see the building I'm in. And that little tree is a little bit in the way, but right there is my window. So I wonder if you go to the sky view. No, not in this shot because we're leaning over to the side, sadly. But with this stellarium, you can see where I've done the photorealistic horizon. This is my window right here. So this is where I'm sitting. Give you bearings. So Canis Major is this big dog, and it looks like, if you paint it like this, it looks kind of like what it's supposed to be. Here's Sirius, and all the puns, I'm really serious. Then this Caroline's cluster is right up here above the dog's head. And right there is that carpet of stars. And you know what? It looks exactly like our carpet tonight. Wow. Thank you, Caroline, for spotting this. I mean, she had to spot that cluster in the middle of a tapestry of 1,000 stars. Oh, it does have an NGC number, you're saying, Stu. I'm so glad you pointed that out because it's not in my targeting software. Let me do this observation and see if it's over here in the observation window. It's not. Can I edit that? Can I add it? I'll just add it down here, I guess. NGC 2360, Stu says. Caroline's cluster is an amazing tapestry of jeweled points of light on top of thousands of more points of light. Breathtaking. We had to just stop and take it in for a moment. Gorgeous. Well below zero up in, isn't it Schenectady, Frank? I can't remember. -8. Ouch. That's just hurts my skin. Andy's got 31. Angela 31 in Glendale. That's cold for Glendale, I bet. Wait. Is it 31, Angela, or is it 63? 31 is balmy for Witchcrone up in northern Wisconsin. Stu is discovered on 26th of February, 1783 by Caroline Herschel, who described as a beautiful cluster of pretty compressed stars near 1/2 degree in diameter. Wow, so she thought it went out here. A perfect and beautiful creation. Almost like counting blood cells. I wouldn't have thought of that. Stu, her notes were overlooked until her brother William included the cluster in his 1786 catalog of 1,000 clusters and nebulae. See, he says. Witchcrone, laugh out loud. Donald Ray, wow. Ezra, I remember you saying that was discovered by Herschel's wife. Nah, I think it's sister. Witchcrone makes me want to visit out there. Renato, good to have you back. Renato, gracias por venir otra vez. Esta noche estamos viendo, ¿cómo se dice cluster en español? Cluster, ¿cómo se dice cluster? De Carolina. Renato is hanging with my pals in Colombia again. Azray, Sirius the dog star, right. Donald Ray, NGC 2360. Frank, correct, Schenectady. Donald Ray, Caroline Herschel. Azray, 59 Fahrenheit. Boy, that's actually warm, Azray. Aren't you in Colorado? No, Arizona, that's right. Look at his name, Arizona. All right, another cluster. How about this Colander 101? So let's grab a picture of this. This is an outstanding picture. I think this will be a beautiful picture for Kevin's wall. Look at that. We're going to send him the highest res we have. This will be like 35 meg, and he gets that because he's that high level of Patreon. Now we're going to go to our next target, and I don't know about you guys, but I'm having fun. We're 9 minutes away from the end of the live stream, and I'm having a fun time. So this is in Monoceros, which is actually a uniform, not a rhinoceros. And we'll slew to this in Monoceros, and it is Colander 101. Herschel named it Herschel 3-8. So while I think of it, I'm going to put it here. Colander with 2 L's, 101, and open cluster in Monoceros. It's like rhinoceros, only with a mono. There you see the scope slewing. Here you see the sky cam slewing. Boy, look at that moon. That looks just evil, doesn't it? Absolute evilness. Wow. So there we are. We're weights up on the west now, with the scope over on the east. Pier East, they call it. Pier East, weights west. Look at the moon. Wow. So our target is bound to be right here in the middle. This is fierce moonlight. Fierce. And this is called Colander 101. You know, I'm amazed, really, by the whole thing of, I mean, who was it? One of you guys last night, was it you, Mike? I can't remember. No, I don't think it was you, Mike. Somebody said last night, are you really going to try the Herschel 400 in 98% moonlight? And I'm telling you, I am amazed that we can get anything on a full moon night. I know a lot of guys, a lot of astronomers that would not want to even turn on their gear, let alone set it up, if they had to set it up, because they'd say it's a waste of time. And here we are in the middle of a full moon looking at reflection nebula that are 15th magnitude, 1 degree wide. I mean, 1 arc minute wide. I'm just fascinated by the whole concept that these objects are up there all the time for us to enjoy. It's like a bunch of Easter eggs hidden in the night sky, and we walk out to our car, if we even do that. If we have our car parked in the garage, we don't even do that. But if we're in a parking lot some night, we come out from a movie theater or a ball game, and we look up and we see the, 100 or so stars that we can see in light-polluted cities, if that many, maybe only 50, and we say, oh, aren't the stars beautiful tonight? We forget that up there in that light-polluted sky, this is Bortle 6. This sky is Bortle 6, where, not in the city, but I mean right here where we are at the Emerald Hills campus, we are in the middle of Bortle 6. And in the middle of Bortle 6 with a 98% moon, it amazes me that these Easter eggs are up there for us to find. It shouldn't be possible. In this context, I'd say a cluster would be cúmulo, some type of group. I think that's a good idea. Cúmulo. So it's cúmulo abierto. Cúmulo abierto. Stu says 81 Fahrenheit. Oh my goodness. That's like sweaty, Stu. Let's look at M52 in the northwest. I think that's a great idea. ASRAE, M52 coming up next. This is also known as NGC 2251. Now see, we wouldn't have known that because it's not here in my targeting software. Oh, you know what? There's another column. Let me make this a little wider. Whoops, that's the wrong thing. Let me make this a little wider. I spoke too soon. So what happens is, when there's a natural name like Caroline's cluster or Colander, it bumps the NGC number over to this common name 2. Sorry about that. So we're on Colander 101 or NGC 2251. And let's show chart. So for orientation's sake, we're looking toward the south-southwest. And in the south-southwest, here's Orion. And square away from Orion's belt. So in other words, not in the direction that Orion's belt would point, but square up away from it is where we're going. And this is not a part of the sky. It's in the direction of Gemini. And again, I think we're going to be from the moon about 26 degrees, just right outside what I consider to be doable on a full moon night. Even though I feel, matter of principle, to go on a full moon night, it's still within 20 degrees. It's not worth it. Here's the field of view of the RASA, the red rectangle. This is a fairly small cluster, isn't it? See, now I would have a hard time figuring out what is the cluster here. Is that the cluster? Right there in the middle, I guess. Or would this whole thing be the cluster? Probably just this thing in the middle, right? NGC 2251. (12 magnitude for surface brightness. So this, I mean, this is very dim, but look on, is that right? Wow. Oh my goodness, we're seeing a ton of stuff tonight. No wonder you like these, Mike. Let's reset the display histogram again and pull this down to maybe right about there. And then bring the mids up only just a hair, because really we're trying to see stars, not nebulosity. Wow, it's beautiful, isn't it? Don't forget that SharpCap has this deep sky image annotation. So you can, of course it's off a little bit, isn't it? And what we do to fix that, if it's off like that, it's not real helpful if it's off. We do a plate solve only, and that lets the telescope kind of figure out its alignment perfectly. Since we're kind of zoomed in here at just a 2-degree slice of the night sky. This is NGC 2251. NGC 2251 is a fairly, what would you call this, a sparse cluster, but still beautiful, mainly because of the Milky Way background stars, I think. Now let's do our deep sky image annotation, and right there in the middle is NGC 2251. So I don't know, I mean, if that's the extent of it, I don't know that I would have seen this. How about you guys? Would you have considered that a cluster if you were one of the Herschels? Caroline, Gumaro, let's look at M52. I would never doubt you. Definitely hot. What software do you use to control the scope again? Deep sky planner if we're controlling the scope by the target list. If we're controlling it by just going to Stellarium and picking something out, then we're using Stellarium and it's hooked to the telescope. So we got three things hooked to the telescope. We've got Stellarium, Deep Sky Planner, and also SharpCap. All three are connected through ASCOM to the telescope. Cumulo poco, right, Mike? 5.7 arc minutes. So that's very, very small. I would have never discovered this. I mean, I just wouldn't have. And this is called, what did we decide? NGC what? 2251, right? Let's look this up real quick and see what NGC 2251. 2251 on page 52. Stephen James O'Meara says, it's a small and indistinct open cluster, a little more than, he tells the location. It's a coarse scattering of suns, elongated with no central condensation. It may be difficult to see it well defined from a city or light polluted suburb. He talks about you have to use averted vision to see it as a cluster. It looks like the snake that swallowed the elephant. What? A snake that swallowed an elephant. How does he get this stuff sometimes? 2251, where was I? I just got so distracted by this metaphor here. Irregularly long gathering of some 24 suns of mixed magnitude. Okay, I can sort of see that. A tail of 4 stars extends to the north. So this must be, those must be the tail of 4 stars. Centered on a hazy, elongated, partially resolved core. Wow. So maybe it's hazy in the middle of that. Let's bring in a little haze. I feel like some kind of movie producer or movie director. Cue the haze. And some special effects guy says, guys, he wants haze. You know, I think the haze is basically made by the starlight. I'm not seeing a lot of haze, unless it's just lost in the moonlight. With imagination, the cluster looks like a Mexican free-tailed bat in flight. Mexican free-tailed bat in flight. A Mexican free-tailed bat. Mexican free-tailed bat in flight. Anybody see it? Cumulo poco, 5.7, nondescript, 63. Azray says, I usually use Nina to locate and focus, then go back to SharpCap if I'm live stacking. Oh, I see what you're saying. Yeah, I guess for an astrophotographer, you want to focus every time. And whereas in EAA, the emphasis is on 8 or 9 minutes max per target. We're on 9 minutes, but that's because I got carried away with the bat. Little on both ends and large in the middle. Inverted vision, squinting. Maybe he was squinting too hard, Stu says. Man after my own heart. Andy, that's the snake that swallowed the elephant. Azray, you're too funny, Doug. Witchy Crone, giggle, Andy. What was he smoking, Andy says. You got my line there, Andy. That's great. Stu, imagination, maybe hard drugs. Peyote, Andy says. Andy can't see it, Stu. Yeah, it totally looks like that. Stu, you are being so sarcastic. Witchy Crone, yep, I see it. Does the word pareidolia apply? Armando Magallanes, hello from Chihuahua, Mexico. Armando, tenemos ahora esta noche otro que es de Colombia. Por favor. Stu says, laughing out loud, we're still kind of trying to make this bat thing happen. Well, let's take a picture of the bat. And it is after 11. We're going to do one last object just for fun, and that's M52 by popular request. Next target, I think it's safe now. And this is going to be M52. And then we come over here this time and back off and look for M52. So it's in the northwest. That's a good piece of sky for us. Here's Cepheus, and it's up about 21 degrees. Plenty good. Oh, the salt and pepper cluster. Why do they call it the Cassiopeia? Why do they call it the Cassiopeia salt and pepper cluster when it's not in Cassiopeia, is it? Oh, did I say south? This is northwest. I was going to say northwest. So it is in Cassiopeia. It's the Cassiopeia salt and pepper cluster. Okay, so what we do is we just, now we go current object and then slew. And so in this case, we're using Stellarium, the planetarium software, our star chart software, so to speak. And the reason we do that is because it is, okay, I'm going to admit it, when you're using this deep sky planner on a certain target list, and then you decide you're going to go to another object, it's a little bit of a hassle. You kind of have to like save this target list first, and then after that, you have to make a new target list or open up. I keep one called next target. I think I keep to add things to. It's a little bit of a hassle, I'm sorry to say, but that's because it's so target list driven, you know. So here we are. You can see our, if you look real closely, that's our RASA sort of crosshairs, and this is our RASA field of view showing us what we're gonna get the bubble nebula and this in the same frame. You know what I think we should do? Let's pick a star here, and let's do current object, slew to that star if we don't mess up our next target software. And the reason why I'm saying that is because we'll get both square in the frame that way. In fact, why don't we do this? Why don't we pick a star right here, kind of between them, and do that one? Yeah. Okay. Now we'll let that settle a second. And I hope we won't mess it up. No, I don't think we will, because we moved it a couple times. Look, there's already that salt and pepper cluster, but we're not seeing the bubble nebula yet. Oh, sorry. I have you guys still on the slewing. Let me look. NGC 7654 is an open cluster of stars in the highly northern constellation of Cassiopeia. Was discovered by Charles Messier in 1774, halfway between, yes. Okay, so did we finish out our last observation? What was the thing we observed last? Was it 2251, right? So we finished that observation, didn't we? I think so. Tell you what I'm going to do. While that's, I'm going to say ignore the observed, and I'm going to put this in order of roughly NGC number and try to find 2251. See, you can't do that if it's over here, 22. How in the world? I guess I could just, okay, I don't like that part of it. How can I just do a find here? I gotta admit, that's a little bit confusing, isn't it? Just to, that's still, there we go. We finish our plate solve there, and let's do our, I'm in trouble now saying, what if I just want to find what I just looked at in this observing log? It's, oh, this is going to be beautiful. Look at that. So we'll reset the display histogram first. And then we'll, the color balancing looks okay. It's just our mids are too high. We'll bring the darks over to right here. Boy, how cool is that? Be able to get these both in the same frame? Whose idea was this to go here? This is a great idea. I think this is you, wasn't it, Mike? Didn't you request this? You're the man. Look at this. Beautiful. Let's let that form a while. This is the bubble nebula down here, otherwise known as NGC 7635, Stu. You guys are as bright as the stars with your information. Just want to thank you all now in case we go off soon. Stu, I'm just copy-pasting from Wikipedia. Azrae, thanks for the kind words, Witchy Chrome. Andy, you're most welcome, Witchy Chrome. I'm just blown away by this. It's so great. That was very kind of you, Witchy Chrome. Stu, yes, thanks for thinking I'm smarter than I am. Stu, you know how to look it up. That's pretty great. Not I, Mike says. So who? Oh, so it's Azrae that requested this. This is a great request. So NGC 7635 Bubble Nebula and NGC 7654, the Salt and Pepper Cluster, both in the same frame here, make a great pair. Pretty array with the good ideas. Let's go a little bit darker with this. Like that, maybe? Might be just a bit much. I'm going to hold the Shift key down and find, I'm looking at the Bubble Nebula in particular. Let's zoom in on that for a second. And what we're trying to do is increase the black sky against it. Holding the Shift key down as I adjust this black level, because it makes it very fine tuning. There is a point at which you start to lose some of the information, and then you are actually just shooting yourself in the foot. Maybe right there, and then let's ease up the mids. Now let's back off again. I love this. Doug is our leader. We're in big trouble, Andy. No moon in sight. I'm glad. I've totally enjoyed being here, Richie Crone says. Mike, Doug is the Canis Major, the big dog. Thanks a lot. Doug is just opening the door for us, inviting us in. Thanks, Doug. You're nice, too. Richie Crone. Oh, thank you, Doug. Richie Crone. Try the live stack auto stretch. Okay, but it looks like it's already stretched well. Look at the perfect... Okay. Maybe you're right. Maybe you're right. I agree. Maybe you're right. Azray. Yeah, I think you were right, Azray. I think when we get these mids up, that bubble is going to pop out at us. It made the sky a lot less grainy, didn't it, Azray? You knew. How long have you been doing this, Azray? No fair. You got more experience. That's great. All right, that's 5 minutes. And that's just amazing that we can do that with 5 minutes on a 98% moonlit night. Let's see where the moon is. You're right, the moon is far away, huh? Yeah, you're right. This is a good idea. Chase away the moon, go to the other side of the sky. Where was our target? I've lost. Oh, here it is. 83 degrees. 83 degrees away from the moon. Azray, you're smart. Stu, fella knows his stuff. It's in his name. I learned from our friend Tiago. He's a great at EAA. Yeah, good job, Azray. All right, gang. Well, thanks so much for being a part of this tonight. Thanks to God for making all these cool targets. Thanks to you all who were patient. We've gone past our normal 2 hours by 18 minutes, but I think it's because we did this last request that Azray made. And as you can see, it was a smart idea. It was a good request. We were able to pick up this salt and pepper cluster and the bubble nebula in the very same frame, and it made for a really unique contrast that you don't see that much, do you? You don't see a beautiful cluster like that with a diffuse, I mean, what would that be called in a, what kind of nebula would you call that, I guess? Cassiopeia, and this is called a H2 region, so it's a hydrogen alpha region. Still nebulosity, but it's being lit up by that star that you see there, and it is unique that you can try to get all this in one frame, isn't it? That star right there. It's just blowing up this red gas here and making it look pretty for us tonight. Thank you, guys. Hope you have a great night. Don't forget, if you haven't hit subscribe yet, please do that. Click a thumbs up if you would be so kind. Makes the channel raise and others. If you're watching this as recording, thank you so much for being a part of this recorded version. You stayed till the very end. Hats off to you. Don't forget, you can go look at that merchandise for whatever that's worth. Go to the Emerald Hill Skies channel and then click store. Take a look at what's there, but more than that, click that Spreadshop link and go look at all the things you can order. We'll put more and more there as time goes on. God bless. Have a great evening. Take care. Good night.